If you're a subscriber on this channel, you've probably seen me respraying this van from white color into the color you see on the screen just now. But today I'm having a different problem. The problem is the cylinder head gasket is blown. It's blown between cylinder number 1 and cylinder number 2, and I decided to rebuild the whole engine because I never was sure what condition the bottom part of the engine is. Even so, I made some measurements. I didn't want to leave it as it is. You can see there is some piece of cylinder head gasket that were fallen into the cylinder and got embedded in the pistons as the piston compressed it, and also there is some areas of area visible where gases were passing between the cylinders. You can clearly see it a lot more prominent on the aluminium cylinder head, simply because cast iron block is much more harder than aluminium, and aluminium got a big massive gouge in it. As you can see, the gouge between cylinders is actually quite deep, and it was 0.3 millimeter, which is quite a lot. So the whole video going to be about rebuilding this engine. The reason why I decided to rebuild the engine is because every so often my van can be as heavy as 3.8 ton with all welding gear on the back of it and so on. So I decided that the new vans that comes in, they come in with 2-liter engines, and I think it's far too little for what it needs to do. So decision was made and I went for a full rebuild. Bear in mind, it's the first time I will ever be rebuilding 4-stroke engine, so I never done it before, and hopefully if you guys have much experience and you're watching this video, don't be too critical on it. If you do have some constructive criticism, I'll be happy to hear it, because that's a part of a learning curve and I don't mind that. So basically speaking, idea behind was trying to clean engine completely and repaint it, because when I will be assembling it back together, I didn't want to deal with the nonsense of dirt and other stuff that fallen from the engine during the build. I went on the website to Mali, the company that does pistons and all sorts of car parts, and on their blog there was a recommendation. Basically they were saying that 90% of all failures that happens after engine rebuild is due to contaminations, due to some sort of dirt getting into the engine while it's getting rebuilt. So I realized that it's very crucial factor, and for that reason I want to have everything clean, so there was no space for loose dirt from a cast iron block and loose piece of rust on the engine. So decision was made to simply wash everything off with a degreaser and a little bit of just a brush to remove some loose dirt. And once it's all removed, as you can see, I've already made flanges to cover all important holes and stuff. I was considering to take it outside, shot blast it in the same way as you see me shot blasting the van itself, the body, and basically paint the block. So once it's painted, it's going to be nice and tidy and clean without any sort of rubbish. See the boxes that I have to catch in just oil and various liquids. I use boxes like this for storing the parts, and basically because it was the first time I was doing engine rebuild, I needed to keep everything segregated, everything signed and so on. So now you see the engine being shot blasted, and the gray area of the engine is actually zinc coating, which called Zinga. You can find lots of information about it on the video that related to repainting the van. And the red color paint is just engine paint that I got out of automotive parts store, Halfords in UK. So I spoke to technical guys at the dealers who represented the Zinga company in UK, because I think they're originally from Belgium, and they told me that this material, this zinc rich material, as they called cold galvanizing complex, can withstand temperatures up to 120 degrees Celsius, and 120 degrees Celsius is more than enough for what I need to do, because this engine should never be really that hot. you can still see on the engine the oil pump and the water pump, and at the moment I just kept them on simply for one reason, so I don't have to block all of these holes, and no sun will get into them during the sandblasting process. So here's the picture of various pistons, and you can see this is a piston number 1, and you can see piece of head gasket is actually embedded into the piston. There is also more than just this damage. Bear in mind, because it's the very first time I rebuilding the engine, I didn't knew how much of a damage is acceptable or no, and I didn't want to do all of this job only to find out that I have to do it again later on. And basically I just try to adopt the principle, do it once, do it right. As you can see, there is lots of damage on top of the piston, and there is lots of particles, gasket inclusions in the piston itself. Also, the area where the gasket blown in between the cylinders, that area is actually has a little like born edge on the piston, just right in here on the edge. So that area on the piston is burned out, so I wasn't sure if I can reuse these pistons or not, and so I just elected to go for next size up pistons, which is 0.25 millimeter bigger in size, and it didn't look too bad. It didn't look too bad, but I decided, since I'm going to be doing it, I just do it want to do it once, and I don't want to look into it again for a good while. So basically speaking, I was trying to clean off just stops of the pistons to see if there is any information left on those pistons that could give me details on the part numbers and so on, but wasn't very successful. As you can see, there is still some honing left on the cylinder walls, and some people who were coming in and looking by, they were suggesting that I should just keep everything like it is and not do anything with it, but I just thought, because I'm going to be putting I didn't want to look into this job twice, as I mentioned already. I didn't want to do it twice, 3 or 4 times, so I just thought it's easier to rebore these pistons. So I measure out all of these spacings. Obviously it's not the best tool for a job, however it's the only tool I had, and I didn't want to spend extra money on the tool that I was only going to be using once in a lifetime, hopefully. So I just had the telescopic gauges, and naturally I was using the micrometer just to get my sizes. I've seen lots of videos on YouTube there were people using the verniers, and I don't think it's a really good idea, simply because when you adjust your vernier with to get size, you don't really have that sensitivity to stop whenever you start squashing this telescopic gauge. But where in the inside of a micrometer there is a little ratchet mechanism that are designed to stop without excessive pressure. So it was just a natural choice to use. I've populated this table where we have 5 cylinders, and each cylinder been measured in 3 different locations: top, center, and the bottom, as much as it could reach. So, and I work out all of those sizes and just wrote them down. The standard size was 81.1 millimeter, and as you can see, the sizes on the table, they're not very far away. The issue with that is that the size I had were landing in the middle of specs. So if I would want to fit a new piston rings, and I had to do some machining work just to make sure that they will work fine, then I would end up with a cylinder which would be on the end of its life. So I use the dial gauge to work out the heights for the top dead centers for each cylinder. It's very easy to do. When as you can see, the piston moves up and pushes a needle, and once needle goes one direction and it starts to come back, that will be your top dead center. I needed this top dead center to make sure that cylinder head gasket, which was used originally in this engine, was the right size. The reason why I needed to inspect all dimensions and all sizes, simply because I didn't know what condition this engine was, and by recording this dimensions and all sizes, and I knowing everything from manual, whatever manual workshop manuals say dimension factory tolerances should be, I can work out how basically how far this engine is and how much work will it require. And saying that, it wasn't too bad. I did discover, however, that somebody been working on this engine before, because the shelf bearings on the piston on the cylinder 1 and 2 were made by a company called Schmidt, and the shell bearings on the pistons 3, 4 and 5 were made by Volkswagen and Audi. So that would be very unlikely event that set like this was actually put out from a factory. So somebody been definitely inside of this engine before me. And as you see me doing checking how protrusion of a piston for at the top dead center, that was done for every single one of those pistons, simply because I needed to know the whole picture. Here you see the actual cylinder head gasket, and you can see that it's this completely born through in between cylinders, and the cylinder head gasket has 3 holes as that are used for identify the sizes, the thickness of a gasket. And according to the manual, that is correct gasket for that size of protrusion on the piston. It is actually the biggest size of the heaviest, the thickest gasket was available on the market. Well, was available on the supplier anyway. There was another issue that was happening with the supply. I went and bought parts from a website called autoparts.co.uk, and then the parts wouldn't arrive for a very long time, so I decided to chase these people up, and only to realize that this guy is pretending to be UK company while they're located in Germany. So it was a nightmare to get their parts from them. But basically, according to manual, you can see that with the thickness of with the protrusion of a piston as I had, the thickness of gasket in 3 holes size was correct one. I didn't go in the greatest detail on how to take off some, because it's kind of common logic. But what you see me, I took off the oil inlet pipe, and inside of that oil inlet pipe there is a swarf that was left there from the factory when they cut a pipe and put that flange on. And it was unbelievable because it was sitting inside of an oil pipe, just holding on by a small piece, like a hair thick piece of steel, and you can see a lump of steel lying in there just waiting to get loose and go straight into the oil pump. That was kind of a very surprising experience. Surprising for many reasons. One of them that it's been like this left from a factory, and secondary that whoever been in the engine before me never actually spotted. So here's the first shell bearing start to come out. In all understanding that I have, when everything that I read and I watched on YouTube, that seems to be pretty good condition. And so far, I didn't see any gouges or any sort of things that would actually make it questionable, whether this thing's been run on the bad oil or whatever. Everything looked pretty clean inside the engine. Yeah, same again, the last shell bearing. And when I took out the piston, what I was also surprised that underneath the piston, right underneath the pin, where I forgot the name of a part of it. So the piston is actually quite clean on inside, and it doesn't look like heat was traveling through the piston quite a lot. And all piston rings and everything was moving, freely moving. This engine was using oil and it was smoking quite heavily. However, the piston rings, they're all free moving. I've seen video of some people who's dealing with engine rebuilds and basically machine shop that does engine work, and they were recommending to use Yenmak pistons by Turkish made company Yenmak, simply because they were saying that there was some pistons with the oil with better oil drainage system in them. However, I didn't have the chance to bought them, but the parts that came to from Golden Schmidt, they were also having exactly the same oil drainage as I've seen on Yermak. So you've seen me basically marking everything and putting everything in the bags or in the plastic containers. That was only way I could think that I can actually trace where it's going to be from, because I couldn't imagine how else I could actually go around and get this job done without losing parts or completely forgetting where it's from and how to put it back together. It's not a complex engine, and it's probably one of the simplest engines. However, if you have very little experience, that the speed at which you're doing everything is really slow, and I had to speed up some of these trucks like 5-8 times, simply because I'm extremely cautious. So I use the plastic gauge again in order to investigate how much wear do I have on the crankshaft and on the shaft bearings and so on, just to give me idea how, in what condition it is and whether it meets factory tolerances. So the plastic gauge, the way it works, it's a defined size piece of wax, or at least it looks like a material like a wax, which you basically cut a piece of it and lay down on in between two surfaces between which you're trying to find out the gap and the size, and then you clamp everything together. So basically I'm gonna fit the shell bearing back in and compress everything according to manual. When you tighten up your main bearings, it says you need to torque it to 65 Newton meters and then turn it to a certain degrees. But while what manual also say that when you just checking for sizes, like using your plastic gauge, then it will be just sufficient to torque it to 65 Newton meters. So basically in this part you'll just see me doing that, and if you ever need to measure this sort of things, you'll know exactly. But also you need to do that accordingly to the specification that you will have in your own engine. And I find that finding the manual for the engine is actually quite problematic, because dealers don't want to release it, and it's just nightmare, whether they don't produce them or what. It was a hard one for me anyway, but eventually, without a book, I've got couple of different manuals, and between the cross references and little suggestions and lots of YouTube videos, you can find lots of information online regarding rebuild of your own engine. So basically, as I mentioned, the main bearings is cranked to 65 Newton meters, and I didn't want to crank it all into 65, so I just made it in several stages, so it compresses more evenly rather than moving in a way that something can go squint or twist it, and just trying to avoid that sort of things. But that would probably be just normal common knowledge and practical expectation of if you have any sort of practical skills behind yourself. So you can see a little piece of green plastic, green box right underneath the main shell bearing, and once this main shell bearing is off, what you will see that piece of wax goes squashed into a strip. So the gauge, the paper holder that holds the gauge, also acts as a gauge for a thickness. So you just match the squash bit to the piece on the card, and that gives you size of your gap. It's a really handy tool, and also it comes in different colors, depends on the different size. Also in the manual it says right now I just checked radial clearance and it was perfectly by the book. It's still in the factory tolerances, and you could run probably for quite a long time with this engine for another 200,000 miles easily. However, I wasn't happy with the cylinder itself, because they were in the middle of tolerances. So if I would want to put new piston rings into those cylinders, what I would need to do, I would need to hone them just so that the rings can set it properly. And if I would hone the cylinders, that would be right at the end life size of where they need to be. So decision was made to go for a new set of pistons, which are 0.25 millimeter larger in diameter. And you can see big gouge in between the cylinders, and if you pay attention, what you also see the opening, the hole for injector, and there is a little crack between the hole and the valve seat. Again, manual actually speaks about those cracks, and it says they're not a problem as long as they are within certain tolerances again. But I spoke to people who do machining in the machine shop, and they deal with 1.9 turbo diesel engines, and with this type of engines, basically 1.9 turbo diesel engine is just a 4-cylinder, and they add extra piston to it, and they made this 2.5 liter engine. So they're saying that usually these parts do have cracks and so on, but they're working without any problem, according as manual says. What you also will see that inside of those air inlets and outlets, there was a lot of rough surface areas, like things from castings and so on. So because I needed to skim the cylinder head down to 0.3 mil in order to get rid of those the markings that got the gouges, what I would also need it is the valves to be seated same amount of distance into the head. So for that reason I thought I'll just polish up all ports, because I'm not really worrying about touching the valve seat at the moment. If it does, that valve seat is still gonna be caught really deep. So 0.3 mil, which is quite a lot in the machining world. So basically I went and I polished out all cylinder ports. Again, I didn't have any experience whatsoever, but it does make certain sense to me that the better flow will be, of the air into the engine and out of the engine, the easier it can breathe. Plus, like outlet ports, if it's smooth surface area, then there will be less chances of a heat transfer between exhaust gases and basically the cylinder head. So I thought, because I have this opportunity, I'm just willing to invest a little bit of time and into this work, and all of that been done. I didn't open up any ports to make them any larger or anything like what some people do when you look on YouTube videos for polishing and porting. I just wanted to smooth it off, so everything much more smoother and airflow can go much easier. But this time when I'm making this video, the engine being rebuilt and van done over 2,000 miles now. The first oil change was at 700 miles, and then put new oil, and I've done another 1,300 miles over it, and I can say that van drives a lot better and a lot smoother, a lot much more quicker. It accelerates a lot quicker, but I can't really just say that was because I just polished out those ports, simply because I also done lots of other things into the van. For example, I just replaced pistons, the piston rings, rebored the bores, so everything perfectly straight rather than being elliptical. So as you can see, the air gets in, and then as it goes into the cylinder, it lifts up, and it basically just goes like through a spiral staircase, and when it enters into the cylinder, it's probably just going to have lots of rotational velocity, and I wanted all of that area to be polished out. So so it goes really nice and smooth. And because, as I said, I'll be cutting down on the valve seats to sink the valves deeper, and the old valve guide is going to be replaced as well. I didn't really worry much about doing it, so I used like a soft felt pad and just basically valve tapping component, just coarse type, and use that to polish out all of those ports within cylinder head. The black markings, I wasn't really worried about them, simply because the whole software is going to be short and sink down in by 0.3 mil, so any cracks that I had and any sort of marks, they're all going to be removed as well. Now this is a air intake that I had for the van, and I thought, because it's aluminum air intake, I can actually cut it in half, split it, and polish it out as well, since I started the whole malarkey with this polishing thing. And I just tried to polish one of the ports, as you can see on the right hand side, and it I like the finish. So I thought, when air will be coming in through the big bore and then hitting that wall, I wanted to spread much more easily, much better. So I just cut it in half, and as you can see, because of the EGR valve system within the van, there was lots of tar and just tarry build up on inside of the air intake that probably didn't help with the flow. And once I power hosed it and just washed it with a jet wash, you see the type of a surface area. Many people think it's probably not important, but I think it is, especially at the higher velocities. Maybe at slow speed it's not important. My own experience with the high speed air tells me that once you go into really high speeds, like 120 miles, 100 miles an hour, 80 miles an hour even, then your any sort of drag that you actually get makes a huge difference. So for that reason, I just thought, if I'll polish it all out, then it makes total sense for me that engine should breathe a lot easier. So yeah, basically the final result of all of this polishing is just looks like that. And obviously, because it's aluminium, I can re-weld everything together. Just put one bead all the way around, and that should hold. Aluminum cast, never the best thing to weld, and especially if it's been in contact with oil, simply because oil kind of partially saturates metal to a certain extent, and it becomes problematic. However, I didn't have any major issues with that. Plus, it wasn't the job for a customer, so it was just for myself, and I could deal with the finish that it's all ended up. As you can see on inside, I also polished all out. I left little rough surfaces on the left hand side and right hand side, just to allow air to grab more in there, so it can curve into the corners a lot better. And that's it for this video. In the following videos, you'll see basically rebuild and assembly of this engine, and also there is some work being done on the gearbox, because it was kind of stiff and didn't really work on the second gear really well. It was knocking out second gear and so on, but that'll be in a different video.